Okay, so today we're going to resume our discussion of chemical reactions. So this is chemical reactions part 3, and today we're going to talk a lot about balancing chemical equations. But in the context of doing so, we're also going to discuss reaction types. Okay, reaction types. So I have a little what's the word? Check-in. Like it's going to count as a quiz grade, but it's just a completion thing. So I have a little thing for you to take a look at, and what you're going to be able to do is you're going to be able to take that to just kind of give me an idea of where you are in this process. Okay, so I want you to all finish the little check-in assessment. It's a Google form. All right, so today we're talking about balancing chemical equations, and so we'll start with one of my favorite examples, and I'll actually show you a really cool thing that you can see take place. So before I'll go ahead and stop this share before I actually show you. So let me bust out this video, because I think you'll find it really interesting. So okay. So like, you think of metal as something that you heat up, right? You don't think of metal as something that ever catches on fire, but that's actually not true. Certain metals can totally catch on fire. So magnesium. Let me show you this this really cool little video, because this is one of those demos we'd love to do outside, but can't really do that right now, at least not easily. So I'm going to show you this cool video really quickly, and then we'll get on with class, because they're related. So this is going to be our first reaction of the day.
This is magnesium ribbon, 75 feet of it. This is actually fairly cheap. It's $5 on Amazon.com. And this can be used for starting campfires, because magnesium, there's not much that can put that out. It'll even burn wet. I tried using a lighter to light a small piece of it. It actually takes a little bit of time. The fastest way to do it is to get a blowtorch on it. But for camping purposes, it's better to buy chips or powder of it, because that'll light up faster. So I'm going to take a small portion of this. All you got to do is bend it like this, really tight, like fold it, and it will automatically snap. Stuff burns very hot and bright. You shouldn't look directly at it while it's burning, because it's very bright. I'm going to put it on top of bricks so it doesn't melt the asphalt. And I got a blowtorch here. There it goes. Burns very bright. It makes some smoke, but it doesn't burn for long, because this isn't a big piece. You can actually buy bricks of it online. Those bricks, you can shave them, you can burn them as is, but if you like the whole brick, it'll probably melt a hole right through whatever you put it on. Unless you put it on a rock, it may crack it. As you can see, it not much. The ashes you can now blow away. I'm going to try.
So that white stuff that you see there is called magnesium oxide, and we're going to talk about that in just a second. I'll go ahead and finish the video. It looks like he's going to light some more magnesium on fire.
A little bit bigger of a piece to show you on the video. Okay, here is 18 inches. That is the most of it I'm going to do now. I'm going to ball it up. Like a ball of it.
So if you notice, when he scrunches that up into a ball, there's still not, like, there's still a lot of space in between the little ribbons, right? So like air can get into any surface on the ribbon for the most part. So that thing can still burn very fast.
Put it down. Get the torch. There we go. That flame's going to get much bigger than the last one. It makes some smoke. I don't know if that's toxic, so I'm not going to go in it. You can
Yeah,
see
shouldn't
it's
breathe that.
twinkling, making some little sparks. Very bright to look at. So I'm looking at it on the screen. That helps a lot. Not going to burn for long. It'll be out in a few seconds. This is a good product, especially for starting fires. I'll make another video of this. What happens when you pour water on it? As you can see, it's not burning anymore. It's just super hot. That's what you're seeing now. It's very red. Actually, on the screen, you can't see it. It looks white. It's just ash.
Okay, and that's that. So that's the chemical reaction we're going to start with today. And then I'll stop this share and I'll get the whiteboard up. So we're actually going to start with that reaction today. So this is magnesium combustion we're looking at. So that's a really cool reaction. So I guess before I start with the chemical formula, does anybody have any questions about what he or she just saw? Okay, and Alex, you're here. Alex, we've got to all be on video, okay? Good to see you, buddy, but please go ahead and start your video.
Do we write these as notes?
What now? What now, Ben?
Do we write what you're about to write as notes?
Yeah, you're going to write these in your notes. We're all going to submit our notes today, just like we always do. I'll put that
Right.
assignment up shortly. It looks like I forgot to do that. So does anybody have any questions about that magnesium burning video that we just watched? No questions about the magnesium? One of the things that I thought was cool about the magnesium combustion that I didn't know was that magnesium combustion can be used to start campfires. I didn't know about that. I think that's really cool. So I'm pretty happy that to know that. Okay, Alex, are you there? I don't even hear you. Like, what's going on? Are you there, Alex? Okay. Alex, I don't know what you're up to, but like I'm leaving you marked absent because your mic is turned off and you're not here on video either. So you're just absent. Okay. Alex. I'm gonna send Alex a little private message. Okay. All right, so I just messaged Alex. Okay. All right, so that was our demo, and magnesium combustion's obviously really fun, right? And it's a really cool reaction to start with when we're talking about balancing chemical equations. Okay, so let's just get one like important fundamental thing up front. So balanced chemical equations So guys, again, make sure that you're putting this in your notes, and then make sure that you're ready to upload pictures of those notes. So those should be handwritten. So Ben, I don't see how you're writing any handwritten notes. Are you actually able to write notes like that? Can't hear you, Ben.
Oh, sorry. Let me get my notebook. Ah, jeez.
Okay. So balanced chemical equations have the same number or count of each type of atom on both sides of the reaction arrow. Okay? And why is that? Because atoms are neither created nor destroyed during chemical reactions. Okay? Neither created nor destroyed during chemical reactions. That's the deal.
Wait, Dr. J. Can, are we supposed to write the notes in our notebooks or on the computer, and then we
In
put
your
the
notebook, don't type it. Put it on some kind of paper, okay? Because you're gonna upload a picture of some sort of paper, okay, to Google Classroom for your
All right.
notes assignment for today, okay? And I'll see if I can't get
Yep.
that put up through my phone right now. So while you guys are doing that, while you're copying down right now. So we got 1A. Okay. So I just uploaded your notes assignment, or I just posted your notes assignment, or I'm just posting your notes assignment on Google Classroom. It should go through right now. Okay. So may I erase the board, or are we still copying down?
I'm good.
still copying down.
Okay.
Hey.
Okay. Just got posted. All right. So still copying. Okay. So this is the thing with balanced reactions, all right? You can't lose atoms on either side. So you got to have the same number of each type of atom on both sides of the reaction arrow. So that's very, very important. All right. So Ben's still copying. Who else is still copying? No one else? Okay, so then Ben, just let us know when you're done. Eduardo can't see you. Alex, I don't even know if you're here. I got you marked out, absent Alex.
Oh, neither created or destroyed.
Okay.
Damn it. Ah. Okay, you can take it off now.
All right. So I'm going to erase this board. Guys, just do a quick screenshot if you need it, but I'm going to erase it in 3 seconds. So 3, 2, 1. There it goes. All right. So here's the reaction that we just saw. This is magnesium combustion. So notice this idea of reaction type is still really important, okay, to us. So this is a combustion reaction, right? And so what was happening in this combustion reaction? What does combustion mean? Who can tell us? And then how do we know that that was a combustion reaction? So if you need to, look at your notes from last week, but how do you know that was a combustion reaction? And Ben, you got to sit back up, buddy, because you got to be copying notes on all this, okay?
Yeah.
So we all have to be copying notes this whole time. I'm not going to wait for people to get caught up. So you just have to save a screenshot or something and do it on your own time. I don't know. So
Dr. J, can I answer?
yeah, Abraham, go for it, buddy.
A combustion reaction is I believe it's a violent reaction with O2, and light and heat.
Good. It's a violent reaction with oxygen that produces light and heat. So if you noticed, that magnesium combustion took place where? Was it underwater? Was it inside of oil, or was it in the open air?
Open air.
Right. And the air is 21% oxygen, okay? Everywhere on planet Earth, 21% oxygen. So that's why that magnesium was able to combust so readily. So what happened, right? Well, we've got a balance equation. And the first thing we have to understand are what our reactants and products are before we start doing any balancing, okay? So we go like this, Mg plus, and this is, we can start using, we're just gonna leave it alone right now because I don't have much board space. Mg plus O2, I was gonna talk about state indicators, but magnesium is a solid, O2 is a gas. And then these yield that white powder that you saw, which was magnesium, sorry, let me give a little more space. Magnesium oxide, okay? So the problem with this chemical equation right now is that we don't have the same number of each type of atom on each side. Who can tell us which one is off? Okay, Alana, actually, can you tell us which atom doesn't have the same amount on both sides? There are only two atoms. There's magnesium and there's oxygen. Okay, magnesium here, oxygen here, magnesium here, oxygen here. So Alana, which atom is not balanced? Which atom doesn't have the same number of copies on both sides of the reaction arrow?
Magnesium.
Magnesium? Okay, so there's one magnesium here and one magnesium here. Are you sure?
Oh no, I mean oxygen.
Okay, how many magnesiums here? Or sorry, how many oxygens here?
2.
Two. How many oxygens here?
1.
Okay, so that's unbalanced, right? So
Yeah.
one thing that someone might like to do, but this would be wrong, and so I'm writing it in red, you might like to put a little 2 there. But here's the problem with that. If you write a 2 as a subscript to the O, you're changing the product itself. This would no longer be, that's fine, Jamie. This would no longer be magnesium oxide, it'd be magnesium dioxide, which doesn't exist. So that's not a thing. So we're not going to change the chemical, okay? So we can't do that, right? But here's what we can do, okay? We can actually do this. We can say that there are 2 magnesium oxides, okay? And if that's the case, right, now I've got 2 copies of this single chemical here, 2 of these things. Okay, so that gives me what? That gives me 2 magnesiums and 2 oxygens, okay? So if I've got 2 oxygens on the right, have I balanced the situation on the left? How many oxygens did I have here, Alana?
2.
Right, so now the oxygens are balanced. But what about the magnesiums? Now I've got 2 magnesiums on the right. Do I have 2 magnesiums on the left?
No.
No. What do I need to do to that magnesium on the left?
Add it to the other one, right?
So if we've got 2 on the right, how many do we have to have on the left to balance?
2.
2. Okay. So then what we can do is the same trick we used on the right, okay? Just like we put a 2 in front of this entire compound, we can do what to this magnesium here?
Add 2 on it.
Exactly. So we put a 2 right there. Okay. So now that's a balanced chemical equation. 2 magnesiums, 2 magnesiums, 2 oxygens, 2 oxygens. Okay? That's a balanced chemical equation. Okay. Totally balanced. Okay. So let's stay with combustion, okay? Because I like combustion reactions. So combustion reactions are fun because they involve things burning and popping. So here's another fun combustion reaction that you guys, I think, will enjoy seeing. So I'm going to go ahead and pull up another one that's really fun. So let's go hydrogen combustion demo. Okay, so let's see if this thing comes up. Yeah, this is fun. And this is just, that's a long, it's a long reaction. This is fun. Okay, so we'll watch this one.
So let's take a look at the
Okay.
So let's take a look
God,
at the
calm down. Okay, so I'm gonna stop sharing this screen, and then I'm gonna show you something over here on my other screen. So I've got like two different computers going here. I've got my iPad and for my drawing, and then I've got my laptop for my videos. Okay, so this is really fun. So this looks like a really cool
So
college
let's
professor.
take a look at the reaction of hydrogen and oxygen. My hearing is bad enough, so I'm going to put these on, just so I don't have to hold my fingers in my ear. There's a seal to keep the hydrogen in. And actually, I filled it from the bottom, so there's a little opening on the bottom. I'm going to take that off. And now, on the top here, I have an opening. If I light this, let's light this baby. What happened? What do you think was going to happen? What do you think was going to happen? Well, you've seen the hydrogen-oxygen reaction before. But remember that in order for hydrogen and oxygen to react together, we got to have both hydrogen and oxygen. If I have a can filled with hydrogen without oxygen, we can't have a reaction. I only get a reaction where the hydrogen escapes from the can. So, what just happened? What just happened? Well, as the hydrogen was escaping out the top of the can, what was going in the bottom to replace it? Well, air, and that air contains oxygen. So as the concentration of hydrogen in the can was going down, the concentration of oxygen in the can was going up, and eventually we reached a point called the explosion limit. And when the ratio of hydrogen to oxygen got to a certain point, then the reaction between them occurred very rapidly, and we got the familiar combustion, the familiar explosion reaction. All right, so you just got your first lesson. The reaction rate, or the rate of a chemical reaction, is going to be dependent on the concentrations of the reactants. I only get a reaction where the hydrogen escapes from the
That was pretty cool, right? So this is the reaction we're going to look at right now. So I'm going to get my whiteboard back up. So does anybody have, so first off, I couldn't have presented that better. That was just, the way the professor did that was just perfect, right? So, he talked a little bit about reaction rates, which we're not going to talk about, at least not yet. But does anybody have any questions about what he or she just saw? Okay. So you can chat me too. You can just send me like a PM chat, or you can send a group chat or whatever if you'd rather ask the question that way. I'm just going to give everybody 30 seconds to have a question. Okay. Yeah, good to stand up a little bit. Oh man. Okay. All right. So if there aren't any questions right now, then we're going to go ahead and take a look at that particular reaction. So here's what was going on. Okay. Here we are. So this is hydrogen combustion. And for the record, for that combustion reaction, did we see light and heat given off? Alana's
Yes.
nodding her head. Yeah, right?
Yes.
We clearly saw both light and heat. Okay. Alex, you there? All right, I don't know what's going on with Alex. Alex, if you're there, you gotta send me a little chat, okay? Let me know that you're there. Send me a message. Okay, so hydrogen combustion. All right. So, okay. All right. So what was happening, right? So these are the two gases that were reacting. So we had H2 plus O2, okay? And they're actually producing H2O. Okay, water is being produced. They're not going to produce H2O2, which is hydrogen peroxide. That's not happening there. So they're producing H2O, right? So first question is whether this equation is balanced, right? Is this equation balanced? And so who can weigh in on that right now? I want to hear from somebody new.
Um.
So Abraham, you've shared out earlier, right? So I want you to hold your answer. I'm going to check in with you in a bit. Okay, I'm glad you have an answer to give though. So I want to hear from Eduardo. Eduardo, does this reaction look balanced to you? Go ahead and unmute your mic. Eduardo, does this reaction look balanced?
Yeah.
It looks balanced. Okay, so you have the same. What does balanced mean? What does it mean to have a balanced chemical equation?
And like it has the same numbers. Oh, I'm sorry.
The same numbers of what?
Hydrogens? Was that what
And
it's
the
called?
same numbers of what? So the same numbers of hydrogens and the same numbers of what if it's balanced?
Um,
What's this guy called? He's not hydrogen, he's
oxygen.
oxygen. So you'd have to have the same number of hydrogens and oxygens. Okay, let's look. How many hydrogens on the left?
2.
How many hydrogens on the right?
2.
How many oxygens on the left?
2.
How many oxygens on the right?
2.
No.
Oh,
We're-
0, my bad.
No, there's not a 0. We have an O, we just don't have a number. So whenever you see an element, right, without a number, we always know that there are how many of that element. Who can help Eduardo out on this one?
It's one.
One, Therese, thank you, okay? So we only have one oxygen. So Eduardo, back to you. If there are 2 oxygens on the left, but only 1 oxygen on the right, then is the equation balanced?
No.
No, right? It's not balanced. Okay, so we have to balance this chemical equation. So what we're gonna do, okay, I wanna give you 2 minutes, okay? I'm gonna set my timer for 2 minutes, and I want you to try, okay, everybody try on your own to balance this chemical equation, okay? Just give it a shot. We only get good at this if we try, okay? So, hey Siri, set timer for 2 minutes. All right, and
Okay, your timer is set for 2 minutes.
just go ahead and try to balance this thing. All right, we want the same numbers of hydrogens and oxygens on both sides without changing any of the chemicals. So H2, O2, and H2O, they don't change, okay? Their subscripts cannot change. We can only change the coefficients. That means the numbers that come in front. All right, go ahead. So Jose, you'd have to write the whole thing, okay? So thank you for sending me a message, but you'd have to write the whole equation out. Like, for instance, like that, right? So like that's a balanced equation, Jose. So if you can write one out like that, that'd be awesome. If you can just show me, maybe you have it figured out, but you just make sure you show me the format so that I'll know. Okay, so all right, so is anybody willing to weigh in, or do we need a little more time, or what's going on here?
Can I give an educated guess?
Okay, Abraham wants to give it a shot. Alana, are you ready to give it a shot too? Yeah. Okay. So Abraham, take a stab at it.
Would it be H2O2?
No, you can't. Remember, you can't change the chemical itself. H2O is the chemical. So remember, Abraham, I wrote that 2 there, and I said you couldn't do that.
Okay.
Okay, so we can't do that. Alana, what do you think?
I put 2H2O.
2H2O on the right. Okay.
Mm-hmm.
Is that all?
That's what I put. I just took a guess, but
Okay, that's not a bad guess, right? Let's look at what that does. That accomplishes something for sure. So watch. Now we have 2 copies of water. Okay, so we have 2 water molecules, which means we've got 2 O's. Okay, because each water molecule has how many oxygens?
2.
No.
I mean, no. Oxygen?
Yeah,
1.
1 oxygen per water molecule. Okay, so now you've got 2 waters, which means you have 2 oxygens. And look on the left, right? How many oxygens did we have?
2.
Okay, so now we've balanced the oxygens, but let's think again about the hydrogens, right? Every time you change a whole chemical, you change all of its atoms, or how many there are total. So we've got 2 times H2 over here, right? So 2H2. Okay, so what's 2 times 2?
4.
Right. So then what do we need to do over here to balance the hydrogens? If we've got 4 hydrogens here, how do we fix that over here? Therese, you got an idea? What do you do, Therese?
You put it 2 in front of the H2.
Nice. Okay, does that make sense, Alana?
What?
Does that make sense, Alana?
So she said just to add the 2, like
In
in
front of
front,
each 2, yeah. Let's see if that makes sense, right? So Alan, very good, Alan. We just got your chat, very good. So 2H2, right? How many H's are there on the left side?
2.
Well, 2 times 2 equals what?
4.
Right. We've got 4 H's on the left, and we've got how many oxygens on the left?
2.
2 oxygens, okay? 2 oxygens, 4 H's. Now let's look at the right. 2 times 2 equals what?
4.
4 H's. And then you've also got to think about 2 times 1 equals what?
2.
Okay. 2 oxygens on the left, 2 oxygens on the right. 4 hydrogens on the left, 4 hydrogens on the right. Okay? We're set, right? That's a balanced chemical equation. Okay? So I'm going to erase all of this extra stuff because I feel like that gets a little bit confusing. And then
So-
I'm just going to go, you kind of have to see that presented. And then here you go, right? 2H2O and, sorry, 2H2 plus O2 yields 2H2O. Okay, that's our balanced chemical equation. All right, that is balanced. Okay, so we've got about 10 minutes of class time left. So let's see. So I want to do 2 things. We're going to hold off on our check-in. I feel like we need a little more class time with balancing chemical equations to do a full check-in. So even though I've got your little check-in Google form put together, we're not going to do that today, okay? We're going to do that next time. So what I want us to do right now is just make sure that we've all turned in our lecture notes, okay? So I'm going to grade those like immediately. So while you're putting, and I'll stop sharing this screen, and I'll start sharing my actual screen. So I'll start actually putting your grades in on Google Classroom right now, or I'll open up the Google Classroom window so we can all see who's turned in what. So that's what I'm going to be. I don't know, maybe I can't do that. I'm not sure, but I'm actually going to be looking at Google Classroom right now. So go ahead and get on Google Classroom and put in your start turning in your notes for today. And then what I'm going to do is I'm going to go ahead and track that. And then we're going to have a little bit of a chat afterward, just talking about the events going on in the world, because this whole coronavirus pandemic thing, this is absolutely, something we should be discussing in chemistry. So right now, what are we all doing?
Turning in our notes for today.
Good, turning in our notes, very good. And I'm gonna go ahead and post the notes assignment on Google
Wait,
Classroom.
do we just put it up to the camera, just take a picture like that, and then
Yes,
just?
sir, that's exactly right, Ben. That's exactly what you do, okay? Very good.
But isn't it like usually when you do it, it like comes out like somewhat blurry?
Just do your best.
All right. Alrighty then.
Okay. So eight of us have turned in. So Brian, Valeria, Jalen, Alan, Alana, Jasmine. Valeria, I don't understand what I'm dealing with here. I've got like is this a picture? Perfect, Valeria. Okay, good job. So Brian, Valeria, Jalen, Alan, Jose, Nancy, Jasmine, and Therese. Okay, you guys are all getting graded on Power School right now. So Brian, Jalen, who else? Brian, Nicholas, Valeria, Jalen, Nicholas, Valeria, Jalen, and then Alan, Alana, Jasmine, Isaac, Nancy, Jamie Lee. Alan, Alana, Isaac, Nancy, Jamie Lee. And I'm putting these, what you're hearing when I type is I'm putting the grades into Power School. Isaac is Nancy, Jamie Lee, Jose, Therese. Jose and Therese. Okay. Abraham, I'm missing your notes. Cassandra and Jonathan, I'm missing your notes. Ben, I don't have your notes yet. Anthony and Alejandro, I don't have your notes.
Wait,
I turned mine in.
does it not go in the lecture notes chemical reactions part 3?
It does, yeah. Is it there?
Oh, okay. No, I didn't. Hang on, I didn't press turn in.
Good, right? That's why we got to do these things.
I turned mine in too.
Okay, so Cassandra's is turned in, and Yartzi's is turned in.
Dr. J.
Yeah, what's up?
I have a question.
Yeah, what's up, Isaac?
So like I don't have my notebooks right now. I don't have my backpack at all. So like I have to move all of my notes to my notebook once I get it. Is that cool?
That's fine, but find some kind of paper to copy this down onto. You can be writing notes on paper right now. Just find some kind of paper somewhere, somehow. Abraham, you got yours turned in?
Yeah.
Okay.
Dr. J, I turned mine in too.
Jonathan, you too? Or is that Brian? Who is that? Is that Alejandro?
Yeah.
Alejandro, okay.
All right.
All right. So let's see. Let me just double check my. Okay. So Alejandro, yes. Good. Brian, Nicholas, Valeria, Jalen, Alan, Alana, Yartzi, Jasmine. Oh, Jasmine, very good.
Turn my name. Dr. J.
Jonathan's that you?
Yeah.
Okay, thank you, Jonathan. All right. And then, Jamie Lee, let me check yours. Because you put a picture on it. Very good, Jamie Lee. All right. So, Eduardo, I don't have yours, Eduardo. Teresa's are turned in. So, I'm missing a few. So, all right. So, is this whom we have right now? All right. So, I want to go ahead and switch over to just talking about this coronavirus situation. So, if you haven't turned yours in by now, I'm marking it missing. But if you email me by the end of the day, it'll still be counted as on time. Okay. So get that turned in by the end of the day if you haven't already gotten turned in, and email me when you do so. All right. So what I want to talk to you guys about right now is this coronavirus situation. And this is a pretty serious event in our world. And so I'm just going to open up a Chrome window and show you one of the like really important mathematical things that's going on. So I just subscribed to The Atlantic, which is really cool. It's like $50 for a student or teacher subscription for like the premium thing, which I got, which is half of the normal price for the year. So I get the magazine sent to me too, but it's $25 for like a student, right? For just a regular digital subscription, or $30 if you want to get the magazine delivered to you in the mail. So for some of us, that's affordable. And this is a really, really good magazine to read because you can learn, you can learn about all kinds of world events through this magazine. So today's articles are like refreshed from yesterday. So like this article wasn't available yesterday. So man, this is crazy. So the people in charge see an opportunity. So what's going on geopolitically? But we need to look at this one. This is the one I want to actually show you before we get out of here today. And so how the coronavirus became an American catastrophe. And what's really cool is, guys, even if you don't subscribe, all this coronavirus coverage from The Atlantic is free to read. Okay. So I'd love to see you reading this stuff. At some point we may start reading through this in place of our Achieve articles like we used to do. So this particular graph is really cool. And I don't know why. Oh yeah. So there are 3 different graphs we can look at. Okay. So this was the situation on March 1st, right? 15 Americans had tested positive for COVID-19. But you got to remember, okay? You got to remember that at that time, we didn't have widespread testing and a lot of cases were going undetected. So in the past week, with our increased testing capacity, we found that 17,000 people have this virus, okay? And we're still not testing as many as we could, right? So in hard-hit places like California and New York City, or New York State even, the problem is that the authorities are recommending that people who have only mild symptoms do not get tested, okay? So as not to strain the medical infrastructure. So here's the deal, right? Like you can actually see all of what's really going on. So we probably, like here's the initial, and then over time, we've transitioned into this situation. So what this shows us is this is how many cases we actually have. This is how many cases are reported. So it's kind of tough to look at how many cases have been reported, which is over here. And this is the projection of how many we probably actually have, which is actually around 120,000, right? And the number's gotten higher today. So at this point, this is an old graph. So at this point, we've got, on March 23rd, we've got a reported roughly 30,000 cases of this virus. The actual number, you can probably multiply by the reported number by 10. So we've probably got about 300,000 cases just in the United States. That's a reasonable estimate, okay? So that helps you understand that following the governor's orders is really important, okay? stay away from congregating with anyone. And if you're going to get out and exercise, which is a good idea, stay away from any gatherings in the parks. Okay. It's time for us to get going, but does anybody have any quick questions about that? All right. If you do have a question, shoot me an email. I will get back to you. Okay. Otherwise, I hope everybody stays safe. I hope you guys all have a great day.
Have a nice day.
Thank
See you on
you.
Wednesday.
Bye, Dr.
Guys,
J.
okay. Take care. Have a great day, guys. Have a great day. Yep.
Bye.